All right, this is Systems of Linear Inequalities, part 1. Yeah, don't be frightened. There's 3 graphs here. Actually, once we get into it, we're going to find out that 2 graphs are pretty simple. All right, so graph the system. So 1 equation, 2 equations, 3 equations. So let's start with number 1. So there's my x. Y is greater than or equal to x plus 2. Sorry, move that over. Here's my y value. So 0. So y, whoopsies, did it again. Did you guys skip that? Hope you yelled at me. Equals 0 plus 2. Y is equal to 2. Just put 2 there. So 1. Y is equal to 1 plus 2. Y is equal to 3. And 2. Y is equal to 2 plus 2. Y is equal to 4. So 0 and 2. 1 and 3. And 2 and 4. All right, so my points are in a nice line now. If I go back and take a look, equation says that should be a solid line. You can do that. Actually, a lot of times I'll also do y is greater than or equal to x plus 2. You can also label it with the equation. Either one is fine. Just to label the line. It's a good idea. Okay, what's next? We got our thing. We're drawing a line. We should do some checkpoints so we can figure out which side is the feasible region. Oh, look, I can use 0, 0 again. So y is greater than or equal to x plus 2. I'm not thinking this one's going to work. So 0 greater than or equal to 0 plus 2. 0 is greater than or equal to 2. And that's much. So not this side. So for checkpoint number 2, I don't know. How about that one? 1 over 7 up. So y is greater than or equal to x plus 2. See, you gotta be careful, right? This is my y value, it's gotta go there. Greater than or equal to 1 plus 2. So 7 is greater than or equal to 3. And that one is yes. All right. Yeah, this question is about integers. Integers, if you remember, are positive and negative numbers. So I gotta do dots. And there'll be dots above here. Oh my goodness, that's a lot of dots. So we have dots down here. Oh, we can include the line in it. All right, as much fun as that is, I think we're going to be good with that. Okay, so dots on this side of the line. Okay, I'm starting to enjoy that too much. There we go, lots of dots. There's my integers. Now, line number, so it's number 1. Now we'll do number 2. This pen. Now this is a very interesting equation. And we're going to have x, and we've got x is equal to 5 and y. Do you remember how this works? All right, because this looks really weird. What actually happens is 5, I don't know, whatever number you want. Remember, if you have just an x or a y, that's where you have an either horizontal or vertical line. And I always do my other interpretation. It crosses this axis. At this number. There's a specific video on horizontal and vertical lines. If you don't remember how to do it, watch it. I don't remember what number it is. All right, so this line is going to cross the x-axis at 5. So here's my x-axis, there's 5. Before I go any further, and it is a greater than sign, so we need to make a dotted line. All right, that's number 2. Oh, you can't see that. That's number 2 there. All right, see? So if it's an x equals, it's going to cross the x-axis at 5. And sorry, my ruler was a little off there. We still need to do checkpoints. Well, I don't know. Let's do that one. And that's 7 and 2. So we need x is greater than 5. Oh, I said I was doing 7 and 2. So 7 is greater than 5. Yeah. So this is the yes side. Let's do one over here. And that is 3 and 2. So x is greater than 5. The x is 3. Not so much. All right. So we are fine. This was the no. That was the yes. And we are still doing integers, which means lots and lots and lots and lots of dots. Okay, that's enough of you watching me draw dots. Or not even see me draw dots at the bottom. All right. Number 3 is, all right, so x, y is equal to 2, and y. So x is 3, y is equal to 2. X is 5, y is equal to 2. Yeah, it's another one of those weird lines. It's going to cross the y-axis at 2. So here. Hold on while I get a different color pen. And we have an inequality again. Sorry, a greater than sign. So y-axis at 2 is right there. So I'm going to put a nice little dotted line there. I'm going to circle that in green so I know it's the green area. And this is number 3. Let's pick a point under it. Checkpoint. And that is 9, 1. So our inequality is y is greater than or equal to 2. And our point is 1 is greater than or equal to 2. And it's, yeah, not so much. Sorry. It's a little informal. So let's pick a point on top of it. And that has the coordinates of 8 and 6. And I need y is greater than 2. Well, 6 is greater than 2. So that's a yes. So this is a no. And this is a yes. So that means everything above that green line is included. And you didn't see me do any of that. I'm sorry. There we go. Green, but green. Can you save us time? We're looking for where they intersect. So if we keep going up this way, I want to see where the pencil points and the pen points, and now the green points. So right there, that little chunk. Is your feasible region, and in fact, doesn't include this part. It's where they all overlap. Yeah. I'm going to try something here. I'm actually going to flip us to a very cool website called Desmos that can maybe do a nicer graph for us. So be patient while I figure out how to do this. All right, so here's my screen. I'm hoping Desmos is going to work for me. It should be your friend. If I haven't talked about it already, it should be your friend. All right, so y. Now, if you need on Desmos to get the symbols, is greater than or equal to x plus 2. Oopsies. I don't know how to make Desmos do the dots versus real, so it just shades, but it'll still give us the right idea. We just know it's going to be dots. And then I've got x is greater than 5. Whoopsies, doesn't like that. And also we need y is greater than 2. All right, so let's figure out, we need the area. There it is up there, where, I'm going to turn them all off, where, oops, okay, start it. Here's the pink area, and it overlaps with the blue. So our feasible region, I don't know if you can see my mouse, is this kind of purpley area. Wait. I can draw, and we're looking in this area. And then we have this one, so the green one goes there. So our feasible region is this part in here. Which I now realized after I scribbled that I should have made it up. But it's what we had figured out on the graph. And what you can see, what Desmos does do nicely is it does the nice dotted lines when it's less than or greater than, and it does a salt line when you've got the greater than or equal to. All right, end of this video. QL math is awesome.